This video will show you how to calculate the averages and to do the graph for the amount of reactant versus the reaction rate experiment. So first of all, we'll calculate the averages. So we need to add these three numbers together for each of the trials and then divide by the number there are and write the time taken in that box. So for 5 mils, we'll go the three data values added together, press equals, and then divide that by the number that there are. And we're going to round that down to 57. For the next one, we're going to go 50 plus 49 plus 45 equals, divide by 3 is 48. 30 plus 25 plus 24 equals, divide by 3 equals 26. And then finally 30 plus 26 plus 25 equals, divide by 3 is 27. So there are our averages. Now we also just need to check that this table has the information in it that we need. So it needs to say seconds up here because that's what you measured your time in, and you need to have the symbol for seconds here. You also need to have that hydrochloric acid was measured in millilitres. Now you're going to graph this information, the amount of hydrochloric acid, and the average time taken for the bubble column to reach the 7 centimetre mark. You're not going to graph any of this information in here. So we're going to start by putting our axes label on. So our independent variable, the thing that we were changing, was the amount of hydrochloric acid. So we'll put that along the bottom. And we know that that was measured in millilitres. The thing that we were measuring, our dependent variable, is the average time taken in seconds for the bubble column to reach 7 centimetres. Okay, so we start our graph at 0, so 0 goes down in the bottom corner, and then we need to have a look at what our independent variables are. So we need to go across the bottom using these numbers. So we'll put 5 here, leave 2 squares, 10, leave another 2, 15, 20. Then going up the side, we need to go to our highest data point, which is 57. So we'll probably need to go up to 60. So possibly the easiest way to do that will be to go in tens. So we'll go every second, just to make it nice and big, and we'll start down here, 10, 20, 30, 40, 50, 60. We also need a title for our graph, so we need to compare between the two different axes for our title. So we'll say the average time taken for a bubble column to reach 7 centimetres when the amount of reactant is changed, because that now covers our dependent variable, what we're measuring, and our independent variable, what we were changing. Okay, to plot these data points, 5 mils had an average time of 57 seconds. So we'll go across to 5 mils and we'll find 57 seconds and put a small cross. Second one, 10 mils had an average time of 48 seconds. Go up the 10 mil line, put a cross. Next one, 15 mils had an average time of 26 seconds. And finally, 20 mils had an average time of 27 seconds. 20 and 27. Okay, so now what we want to do now is do the line of best fit. So we need to have an even number of data points above and below the line. So we can see here that this data point is below this one, even though this one had a smaller amount than this one here. So what's happening, or possibly happening, is that at this point the reaction is reaching optimum levels. So that means that if you add any more of the reactant, it's not going to go any quicker. So that can happen sometimes, and you'll learn more a little bit about that during the science part of this. So to do the line of best fit, we will try and get an even number of points above and below the line. Now, it helps if you have a see-through ruler because you can place it a wee bit better. If we put it there, we end up with 2 below and 1 above. If we put it there, we end up with 2 above and 2 below, so that's probably better. So we'll stick it on a slight angle this way. So we want to show that even though it started off decreasing rapidly, you then also have this increase, so that's why the line is not quite so steep. And that's all you need to do for that graph.